All right, welcome back to day 2, where we will be talking about arithmetic sequences. Just a reminder about the materials that you need. Please make sure that you're taking very good notes, especially the examples and the practice problems. You need to make sure you're writing those down in your special notebook just for this class. If you're using a notebook or paper from another class, you will not be allowed to use that on the notebook quiz, and you will not. That's not good, because the notebook is where your grade comes from. So please, please, please make sure that you're using your notebook specifically for this class, and that it has your name, the class, and the date written on it in a permanent marker of some kind. So arithmetic sequences. So yesterday we talked about sequences. Today we're going to talk about arithmetic sequences. Please remember that you do not have to write down the conceptual. This is for your information only. If you choose to write down the conceptual, that's great, but you don't have to. So we'll start talking about the recursive form of an arithmetic sequence. We are not going to focus on this, all right? We talked about recursive forms yesterday. I'm not crazy about recursive forms. They're not very practical. So we'll look at it really quick. Remember, the recursive form, you have to know the term previous to it. So in this case, for arithmetic, un equals un minus 1 plus d. Now the big question is, what is d? D is what's called the common difference, all right? Important vocabulary word. I will talk about this quite a bit. You'll be asked to find common differences in arithmetic sequences. Very, very simple. An arithmetic sequence is a sequence that when you use it, you continue to go up by the same number each time. In this case, I'm going up by 2's. That is considered the common difference. If I start with, let's say, as 10, and I go up like this, I'm going up by 3 each time. That is my common difference. So common difference is simply the number that we're adding to get to the next term. So now, recursive form is fine. We're not going to use that very much. What we are going to use is this formula right here. It's called the explicit formula. Please, please, please write this one down. This one I will ask about. Okay, so if I ask you for this on a notebook quiz, you should have it written down. So the explicit form of an arithmetic sequence is looks like this. So whatever term we're looking for, we take u1, which is always the first term. We put in parentheses here. We put n minus 1. And we put our common difference on the end. Common difference is typically given to you or easily found. Once you have all the formula pieces in there, you must simplify. We'll look at that in the example in just a moment. All right, so conceptual, we talked about recursive, we talked about explicit. We're also going to talk about this thing called summation notation. Now, summation, basically when we talk about summations, we're saying we're going to take a sequence and however many terms we find, we're going to add them all up. That's what it means by summation. This little symbol right here means sum. It means I want to add them up. Now right here we're going to talk about, this is going to tell us what term we're going to start with. So most of the time we start with the first term. And the number up here, this m, is the term that we end with. So if we were adding up the first 10 terms, we would say k equals 1, and the m would say 10. All right, so moving on to the real stuff. So example 1, now we have to make sure we're writing these down. I'm actually not doing this one. So this gives us real simple information. It says, find the fifth term, the explicit form for the nth term, and sketch the graph. The graph is not as important. You may sketch it if you want to. It's basically just sketching the ordered pairs. So let's find the formula first. Un is u1 plus n minus 1 times d. Okay. Simply, it's been given to us. u1 is 5. N will never be given to us because that's the number that we're going to use. We're looking for specific terms. D is given to us as 2. Now you should know how to simplify this. I would certainly hope by now in pre-calculus. 2n minus 2, and I end up with 2n plus 3. So here's our formula, un 2n minus 3. Now if we want to find the fifth term, we want to find the fifth term, we're going to plug it in to the n value. So I have 2, it's the fifth term, plus 3, it's going to equal 13. So the fifth term in this is 13. Explicit form is beautiful because we can find any term we want. We can find the 150th term if we wanted to. If I were going to graph this as an ordered pair, it would be graphed as 5, 13. I may want to also graph the first term, which is 1, 5. Okay. So I'm not even going to draw all of the lines on here because it's not a very good graph. 1, 5 would be about right there, and 5, 13 would be about right there. They're ordered pairs. You will notice they do form a line. All arithmetic sequences do. We'll talk more about that tomorrow. All right, so practice 1. Remember, this is where you will pause the video, do the problem, and then check your answer. You may pause once again to check the solution. Example 2, summations. So doing summations, we're going to just do this. It's very, very simple. Summation means I'm going to take the first 4 terms of this sequence and I'm going to add them together. So I'm going to go 1 over 2 to the first term plus 1 over 2 to the second. I said term, that's not what I meant. 2 to the first, that's going to be the first term. Okay, 1 over that. Okay, 1 over 2 to the third plus 1 over 2 to the fourth. Then I'm going to simplify. I'm going to add them all together, and I'm going to use a calculator to do that. This is where we use calculators. All right. So there is my example 2. Okay. Summation, you're going to do this one, or practice, you're going to do this one on your own. Pause the video once again, check your answer. Okay, example number 3. We're actually not doing this one. Okay, so partial sums. Now partial sums make it easy to say that if we want to, say, add up the first 10, we want to add up the first 10 terms of a sequence. Okay, we can do it without actually having to find all 10 terms. So these are nice formulas. The very first one here, okay, we actually have to find, if we're saying the k term, we have to find both the first term and the k term, right, which means we would have to find the explicit formula and then go from there. Formula number 2, you don't have to do any of that. So I'm actually going to use formula number 2. As long as we use the information given, we don't need that explicit term. So this formula here says if I take the k, what term I'm looking for, okay, which is my a term, okay, and I multiply it times u1, 2/3. And I add together, okay, k again, 8, k minus 1, 8 minus 1 is 7, over 2, times the common difference, which in this case is -4/3. Now, this looks like really good fractions, and that's what you have calculators for, and it actually turns out to be a very nice number, -32. Okay, moving on. Practice 3, pause. Do the problem, then check your answer. Here's your answer. One thing I want to talk about with the solutions on the videos is that you don't necessarily have to have them written just like this. When you do the problem on your own, as long as you show your work, I have no problems with, when on the notebook quizzes, having it done your way. Solutions will always have lots of explanations in them, so you don't necessarily have to write all of that down. Okay, that's it.